My name is MHammersla, and for my senior seminar project, I am performing an experiment to assess the impact of ammonia on human health using Drosophila melanogaster. And my mentor is Dr. Richard Sorrentino. Humans become exposed to ammonia by breathing its gas or vapors. The source of ammonia on farms and in commercial locations means that if there is an accidental release, people can become exposed to this harmful chemical. Ammonia gas is lighter than air, therefore it usually rises. However, when there is moisture, especially in humid Florida, ammonia will form vapors that weigh more than the air. The vapors spread along the ground or other low-lying areas, affecting humans to a great extent. If humans breathe in this corrosive chemical, cells in the body can be damaged. Using Drosophila will help me to investigate how ammonia affects human health. The purpose of this study is to subject Drosophila melanogaster, also the common name is fruit flies, to different environmental conditions by setting up stations in different locations and determining how quickly they die or how many offspring are produced in that particular environment. These animal models will be used in place of humans to determine how polluted those common locations are and how it is affecting the human health. Environmental conditions in the Tampa area will be investigated to determine if D. melanogaster experiences higher mortality rates in one location relative to them in an altered location. Over the past few years, the concentrations of ammonia has only increased. Ammonia testing strips will be used to measure the concentration of ammonia of each location. Results will be compared to the already established air quality standards and to positive and negative controls that I will be setting up in the lab. These strips will provide an inexpensive and effective way to monitor low pollutant concentrations. Birth rate and mortality rate in Drosophila will be measured because one may have more of an effect than the other. Once the female flies lay their eggs, the eggs will be counted while the adults will be moved to a new bottle. The eggs will then hatch into larvae, and 4 days later, the larvae will pupate and the adults will emerge. It will be essential to go back every day and count how many adults remain. Death rates of adults will be tracked over the course of a week, and these death rates will allow conclusions to be made about human health. Through the following experiment, it will be made clear that if ammonia levels could be reduced, then mortality rates could be decreased. For my timeline, I will be starting around January 15th to perform the experiment. I will go throughout a month, and then in February, at the end, I will analyze my results. Then near the beginning of March, I will be submitting my first draft, and at the beginning of April, I will be submitting my final draft. For my budget, I will be using a wild type stock of Drosophila, sharing with other members who are using Drosophila as well. Also, food to culture Drosophila, a container to hold the Drosophila, ammonia testing paper, and fly nap, which is an anesthetic for flies. As you can see, my total cost will amount to $115. Animal models will be used in place of humans to determine how polluted common locations are and how it is affecting human health. Motives of this research will include the following: to determine if D. melanogaster experienced higher mortality rates in one location relative to D. melanogaster in an altered location, to determine if Drosophila are capable of producing more offspring in one location to another, to determine whether or not the Drosophila birth rates are dependent on the pollution levels at each location, and to link mortality and birth rates of Drosophila to the natural environment to explain how these results affect the health of humans. As a result of my study, I expect to spread awareness of the effect that their actions have on our environment and try to change human activities. Any questions?